Welcome all. This is lecture number 6. In this lecture, we will discuss volume integral of vector calculus. So, what is volume integral? If vector f be a vector point function and volume capital V enclosed by a closed surface, then the volume integral is equals to triple integral V vector f dV. It may be vector function or it may be scalar function. So, example 1. If vector f equals to 2zi minus xj plus yk, evaluate triple integral v vector f dv, where capital V is the region bounded by the surface x equals to 0, y equals to 0, x equals to 2, y equals to 4, z equals to x square and z equals to 2. So, to solve it, we know that triple integral v vector f dv can be written as, we can write the value of vector f here, and dv can be expanded as dx into dy into dz. Now we take limits of this particular problem. So limits are comes from the region which is x equals to 0 and x equals to 2. So this is the limit for x. Y equals to 0, y equals to 4, this is limit for y, and z equals to x square and z equals to 2, and this is for the z. So we write integral x equals to 0 to 2, y equals to 0 to 4, and integral z equals to x square to 2. So z contains the variable limit, so we first integrate with respect to z. So this entire function can be integrated. So 2z square will convert into 2z will convert into z square by 2. So 2 cancelled out by 2. So z square I minus xj treated as the constant. So xzj and same as yz k under the limit x square to 2 dy dx. Now put the limit upper limit minus lower limit. So when we put 2 in place of z, then it will be 2 square, that is the 4, and minus put the x square in place of z, so it will be x raised to power 4 I minus x and j. X is the constant, so on putting z equals to 2 minus x square, so z will be 2 minus x square, and same as for the next part. So it is the now refined function for the next integral. So in the next integral we will integrate it with respect to y. So on integrating with respect to y, 4 minus x raised to power 4 is the constant. So y will come here, same as x into 2 minus x square is also the constant. So the integral of constant is y, and same as 2 minus x square is the constant, and the integral of y is y square by 2 under the limit 0 to 4 dx. So now putting limit y equals to 4 and y equals to 0. So when we put y equals to 4 here, then it will be 4 into 4 minus x raised to power 4, and when we put a 0, then the entire function will be 0. So the only this function arises. So 4 into 4 minus x raised to power 4 I minus this x 2 minus x square is the constant, and on putting limits upper limit minus lower limit in place of y, we will get only 4 because 4 minus 0 is the 4. So it is here. Now 2 minus x square is the constant. Putting the limit 4, when we put 4, then it is 4 square, it is 16. 16 by 2 is 8 minus 0, so it will be only 8. So 8 time of 2 minus x square k dx. Now this is the function which we can integrate. Integral of 4 is 4x, and the integral of x raised to power 4 is x raised to power 5 upon 5, same as 4 taken outside. Integral of x is x square by 2, and 2 is cancelled out by 2, so minus integral of x cube is x raised to power 4 by 4 j plus 8 time of 2x minus x cube by 3 k under the limit 0 to 2. So on putting the limit x equals to 2 and x equals to 0. So when we put x equals to 2, then 4 2 is 8 minus 2 raised to power 5, that is 32 by 5, and when we put 0, then the entire function will be 0. Same as here, x square means 2 square, that is the 4. 2 raised to power 4 is 16 by 4, that is the 4. And 8 time of 2x, to 2 to the 4 minus 2 cube is 8 by 3. So now see, this is 4 by 16 by 4, that is it will be 4, and this 4 is cancelled out by this 4. So 8 minus 32 by 5 will be 8 5 is 40, 40 minus 32, that is 8 by 5 multiplied by 4, that is the 32 by 5 I, and this is 4 minus 4 cancelled out, so it will be 0 j, and 4 3 is 12, 12 minus 8 4, so 4 by 3 multiplied by 8, so 32 by 3, or we can take 32 as a common, or and take 5 and 3 as LCM, so that is the 15 is the LCM, and take it outside. So 32 by 15 and 3 multiplied to I and 5 is multiplied to k, so it will be 3I plus 5k, so it is the required solution. Example 2, if vector f equals to 2x square minus 3ji minus 2xyj minus 4xk, so evaluate triple integral v del dot vector f dv, where v is the region bounded by the planes x equals to 0, y equals to 0, z equals to 0, and 2x plus 2y plus z equals to 4. So we have to find del dot vector f, that is the divergence of vector f. So to solve it, first del dot vector f is, the value of del is I del over del x plus j del over del y plus k del over del z dot product with vector f, and vector f is 2x square minus 3zi minus 2xyj and minus 4xk, and in the dot product I dot I, j dot j, k dot k is always 1 and rest are 0 and rest are 0. So del dot vector f will be del over del x of 2x square minus 3z, del over del y of minus 2xy, and del over del z of minus 4x, or we can take minus 4 outside. So now partial differentiation of 2x square minus 3z with respect to x is 4x, and partial differentiation of minus 2xy with respect to y is minus 2x, and partial differentiation of x with respect to z is 0. So 4x minus 2x is 4x minus 2x is 2x. So del dot vector f is 2x. Now we have to find triple integral v del dot vector f dv. So it is triple integral v 2x dx dy dz. Now find limits, and the limits comes from the boundary, and the boundaries are x equals to 0, y equals to 0, z equals to 0 are the initial limits, and 2x plus 2y plus z is equals to 4. So from here z equals to 0 and z equals to 4 minus 2x minus 2y, and z, when z illuminated, then only two dimension exists, that is 2x plus 2y equals to 4. So there y equals to 0 and y equals to 2 minus x, and same as for the x. So the limits are twice of, we can take this 2 outside. So x equals to 0 to 2, y equals to 0 to 2 minus x, and z equals to 0 to 4 minus 2x minus 2y. And now variable limit is for z, it contains two variables, so we first integrate with respect to z. So in this particular case this x is a constant, so we can take it outside. So we first integrate dz, and the integral of dz is z under the limit 0 to 4 minus 2x minus 2y. So on putting the limit in place of z, what do we get? 4 minus 2x minus 2y. Now we have to integrate this entire function with respect to y, y because y have the variable limit. So here 4 is the constant, 2x is also the constant, and only y is the variable. So how to integrate? So equals to twice of integral x equals to 0 to 2x, and the integral of the entire function will be 4y because 4 was the constant, 2xy because 2x was the constant, and the integral of y is y square by 2, and 1 2 was there, so 2 is cancelled out by the denominator 2, so it is only the y square. Now putting limit 0 to 2 minus x, that is first up 2 minus x then minus 0. So when we put y equals to 2 minus x, then it is 4 times of 2 minus x, and when we put 0, then the entire function will be 0. So there is no significance of 0. So we can only put the upper limit. So it is equals to x outside 4 times of 2 minus x minus 2x time of 2 minus x, and the value of y is 2 minus x whole square. So now we can simplify it in a two manner. Either take 2 minus x as as common, or multiply this 4 inside the bracket, 2x inside this bracket, and open the whole square of this particular function. And when we apply all this, either the first method or the second method, this will convert into x square minus 4x plus 4. So now we have to integrate this function with respect to x. So we can take x inside the bracket. So on taking x inside, this x square will convert into x cube, this x will convert into x square, and this 4 will convert into 4x. Now we can integrate it directly. So the integral of x cube is x raised to power 4 by 4. Integral of x square is x cube by 3, and integral of x is x square by 2, and 2 is cancelled out by this particular 4, so only 2 remains. Now put the limit x equals to 2 minus x equals to 0. So when we put a 0, then the entire function will be 0. So only x equals to 2 have the significant. So putting the value, so it will be twice 2 raised to power 4 is 16, 2 raised to power 3, that is 8, and 2 square is 4, and 4 to the 8. So now here we can cancel this 16 by the denominator 4 times, and we can add this 4 and this 8. So the sum of 4 and 8 is 12, and this is 4 8 ja 32 by 3. So 12 3 ja 36, and 36 minus 32 is 4. So it is 4 by 3 and multiplied by 2, that is the 8 by 3 is the right answer of this problem. Now moving one more problem. Example 3. If phi equals to 15xy square, evaluate triple integral v phi dv, where v is the region bounded by the planes x equals to 0, y equals to 0, z equals to 0, and 4x plus 2y plus z equals to 8. So now see, this phi is the scalar function, and in a case of triple integral in the vector calculus, that is in the vector integration, in case of triple integral, it may be scalar function or it may be vector function. So we can solve it just like solve the previous problems. So triple integral v phi dv, replace the value of phi. So 15 is the constant, take it outside, and x y square is inside the integration, and the dv is expanded as dx dy dz. Now find the limits as find the limits in the previous problem. So the initial limits are x equals to 0, y equals to 0, and z equals to 0, and for the final limits, z will be 8 minus 4x minus 2y, y will be 4 minus 2x, and x will be 2. So putting the limits 15 integral x equals to 0 to 2, integral y equals to 0 to 4 minus 2x, and integral z equals to 0 to 8 minus 4x minus 2y. Now see, z have the two variables, so we first integrate with respect to z. So in this particular case, this xy square treated as the constant, so we can take it outside the integral. So we write x and y square in this particular manner. So the integral of dz is z under the limit 0 to 8 minus 4x minus 2y. So on putting the limit, we get it 15 time of integral x equals to 0 to 2 x, integral y equals to 0 to 4 minus 2x, y square into 8 minus 4x minus 2y dy dx. Now we have to integrate it with respect to y. So to integrate it, we first multiply this y square inside the bracket. So when we multiply, or we can take this 8 minus 4x together because it is entirely the constant. So just like this we can write here, and this is y square multiplied to minus 2y, it will be minus 2y cube. So now integrate it, 8 minus 4x is the constant. So the integral of y square is y cube by 3, and this y cube is y raised to power 4 by 4. So this 2 is cancelled out by this 4 2 time, and rest are same. And now we can put this limit in place of y, and when we put 0, then the entire function will be 0. So only 4 minus 2x has the significant. So 15 time of integral x equals to 0 to x of 1 by 3 8 minus 4x as it is, and the value of y is replaced by 4 minus 2x whole cube minus 1 by 2 4 minus 2x power 4 dx. Now we can simplify it by taking 4 minus 2x whole cube as a common. So when we take 4 minus 2x whole cube as a common, so and take this 3 and 2 as the LCM, so the LCM will be 6. So it comes to the outside the integral, and when we take it, then 2 is multiplied to this function and 3 is multiplied to this particular function. So twice of 8 minus 4x minus thrice of 4 minus 2x, or multiply this 2 inside and 3 inside this particular bracket. So 8 2 just 16 minus 4 3 is 12. So it will be 4 and minus 8x plus 2x. So it will be minus 6x. 8x minus plus 6x, so it will be minus 2x. So it is again 4 minus 2x. So it will be x into 4 minus 2x power 4 dx. So how to solve it? And we can take 2 as a common in this particular function. So 2 raised to power 4 will come outside. So it will be 2 minus x power 4. Now open or expand this 2 minus x power 4, and 2 is cancelled out by 1 power. So 2 cube is the 8, and 8 5 is 40. And the expansion of this 2 minus x power 4 is by the binomial of expansion of x minus y power n. We can open it with the binomial nc0 x raised to power n plus nc1 x raised to power n minus 1 y plus nc2 x minus x raised to power n minus 2 into y square up to ncn y raised to power n. So we use this particular phenomena, and after using we get it is equals to 16 minus 32x plus 24x square minus 8x cube plus x raised to power 4. Now multiply this x to the entire function, we get it is equals to 16x minus 32x square plus 24x cube minus 8x raised to power 4 plus x raised to power 5. Now we can integrate it with respect to x. So the integral of x is x square by 2, and 2 cancelled this 16 8 times. So it is 8x square minus 32 as it is. X square is the x cube by 3, same as when we integrate x cube. So it will be x raised to power 4 by 4, and 4 cancelled is 24 6 times. So it is 6 raised to power 6x raised to power 4, and minus 8 integral of x raised to power 4 is x raised to power 5 by 5 plus integral of x raised to power 5 is x raised to power 6 by 6 under the limit 0 to 2. So put the limits here. So 8 into 2 square is 4 minus 32, 2 cube is 8. So it is 8 by 3. 2 raised to power 4 is 16. So 6 into 16 minus 8. 2 raised to power 5 is 32. So it is 32 by 5. And 2 raised to power 6 is 64 by 6. So now see, this is, we can simplify it. 2 3 is 6 and 2 3 is 6, 2 2 is 4. And here we can multiply these and these and these, or 8 4 is 32 and 16 6 is 96, and 96 and 32 is 128. So right here 32 8 is 256. So minus 256 and plus 32. So it is minus 224, and 32 8 is 256. So now we can take LCM 3 and 5 as a 15, and on simplifying 224 into 5 plus 3 into 256, so it will be 1888. So now we can simplify this function 128 minus 1888 by 15, and after simplification it will be 32 by 15. So now here we can cancel out this 15 and 14 by 5. So 5 3 is 15 and 5 8 is 40. So 32 8 is 256. So it will be 256 by 3. So it is the required solution of the given problem. Hope you all enjoyed this particular lecture. We will meet in the next lecture. Thank you.